June 20th, 1944. Hamburg. 3 oil refineries billow columns of black smoke that merge into a single choking cloud visible for 40 miles. The installations have been burning since dawn, when formations of American B-17 flying fortresses completed their bombing run and turned for England. But whilst the high-explosive bombs tore open storage tanks and shattered pipe networks, it was the thousands of small, innocuous-looking cylinders that fell amongst them that created the inferno now consuming Germany's third-largest petroleum complex. Each weighs just 4 pounds. Each burns for 10 minutes. Together, they have ignited millions of gallons of crude oil, petrol, and lubricants that will burn not for hours, but for weeks. The Americans dropped the bombs, but the weapon itself was British. Developed in secrecy by Imperial Chemical Industries and deployed in staggering numbers by RAF Bomber Command, the 4-pound incendiary bomb represented a fundamental shift in how modern warfare could strangle an industrialized enemy. It did not destroy through blast or fragmentation. It destroyed through fire. And when directed at Germany's petroleum infrastructure in 1944 and 1945, it proved devastatingly effective. This is the story of how an aluminium tube filled with thermite became one of the most consequential weapons of the Second World War. By 1944, the strategic situation confronting the Allies was simultaneously promising and precarious. The D-Day landings had succeeded, but German resistance remained ferocious. Wehrmacht armored divisions still counterattacked with efficiency. Luftwaffe fighters, though outnumbered, continued to exact heavy tolls on Allied bomber formations. The industrial capacity of the Reich, despite years of bombing, persisted in producing tanks, aircraft, and ammunition. At the heart of Germany's continued military effectiveness lay a single, vulnerable resource: oil. Unlike Britain or America, Germany possessed virtually no domestic petroleum reserves. The Third Reich depended entirely on synthetic oil plants that converted coal into petrol through complex chemical processes, and on the refineries at Ploești in Romania, which provided roughly a third of Axis oil supplies. These facilities represented the German war machine's jugular. Strike them effectively, and every tank, every aircraft, every lorry would grind to a halt. The problem was how to strike them effectively. Conventional high-explosive bombs could certainly damage refineries, but petroleum infrastructure proved remarkably resilient. A 500-pound bomb might crater a road or collapse a building, but refineries were sprawling complexes of pipes, storage tanks, and processing towers spread across hundreds of acres. Blast damage could be isolated, bypassed, and repaired. German work gangs, often comprising forced labor, could restore production within days or weeks. Attacking the same facility repeatedly required enormous resources and aircrew losses that even the mighty Allied air forces found difficult to sustain. Between April and August 1944, the American 15th Air Force flew 5,675 bomber sorties against Ploești alone, losing 282 aircraft and nearly 3,000 men. Production fell, certainly, but never stopped completely. What the Allies needed was not just a weapon that could damage petroleum facilities, but one that could consume them. They needed fire. The 4-pound incendiary bomb emerged from Britain's pre-war rearmament program, when planners at Imperial Chemical Industries received specifications for a weapon unlike any in the arsenal. It needed to be small enough that a single bomber could carry thousands. It needed to ignite reliably upon impact, and it needed to burn with sufficient intensity to set fire to industrial and urban structures. What ICI's engineers created appeared almost absurdly simple. The bomb consisted of a hollow hexagonal body, 14 inches long and just under 2 inches across the flats, manufactured from an aluminium-magnesium alloy. The nose cone was cast iron or steel, providing weight for a vertical fall. Inside the thin-walled body, designers packed thermite pellets, a mixture of aluminium powder and iron oxide that, once ignited, burned at approximately 2,400 degrees Celsius. Upon impact, a striker pin at the nose drove into a small percussion cap containing barium peroxide and magnesium powder. This primary charge ignited the thermite, which then burned ferociously for up to 10 minutes, producing molten iron and temperatures capable of melting through steel plating or setting timber ablaze. The weapon weighed exactly 1.8 kilograms. A Lancaster bomber could carry 2,832 of them in small bomb containers. Manufacturing occurred at facilities across Britain, with production ramping up dramatically as the war progressed. In 1943, factories produced 40.3 million of the 4-pound devices. In 1944, production reached 35.8 million, the slight decrease attributable only to supplemental deliveries from American manufacturers. ICI's chemists had standardized the thermite composition and perfected the firing mechanism to achieve a reliability rate exceeding 90%. The Ministry of Supply coordinated production across multiple contractors, ensuring that components could be manufactured separately and assembled close to operational airfields. Later in the war, British engineers developed the 30-pound incendiary bomb, which incorporated a small parachute to retard its fall and, upon impact, projected an intensely hot flame for 15 feet in all directions. Articles in late 1944 claimed this flame could crumble brick walls. The RAF, with characteristic flair for propaganda, dubbed it the Super Flamer. Between 1941 and 1945, British factories produced 3 million of these larger devices to complement the 80 million 4-pound incendiaries that represented the primary weapon. The operational employment of incendiary bombs against oil facilities followed a carefully choreographed sequence. Pathfinder aircraft, typically Mosquitoes, would mark the target with colored flares. The first wave of heavy bombers, Lancasters, Halifaxes, or American B-17S and B-24s, carried a mixed load. Blockbuster, high-explosive bombs weighing 4,000 to 12,000 pounds, paired with small bomb containers packed with incendiaries. The blockbusters fell first. Their purpose was not to destroy the refinery through blast alone, but to rupture storage tanks, sever pipelines, blow roofs off processing buildings, and crater roadways, hindering firefighting effort. Then came the incendiaries. Released from small bomb containers at altitude, thousands of 4-pound devices tumbled earthward, spreading across the target area. Upon impact with storage tank farms, processing towers, or oil-soaked ground, they ignited. Here, the weapon's true effectiveness manifested. A single 4-pound incendiary burned for 10 minutes, generating intense localized heat. But when hundreds struck an oil refinery simultaneously, they ignited the petroleum itself. Crude oil, once aflame, proved extraordinarily difficult to extinguish. Aviation fuel, leaking from ruptured storage tanks, created rivers of fire that spread through the facility. Even the heavy bunker oil used in industrial processes burned with persistent intensity once raised to ignition temperature by the thermite. Reconnaissance photographs, taken days after major raids on Hamburg, Bremen, in synthetic oil plants in the Ruhr, showed installations still burning. Fires at some refineries persisted for weeks. German fire brigades, already stretched thin by Allied bombing of cities, found petroleum fires nearly impossible to suppress. Water was ineffective against burning oil, which simply floated on the surface and continued burning. Foam agents remained in short supply, and whilst German crews struggled with one blaze, the RAF and USAAF would return to strike again. The strategic oil campaign reached its decisive phase between June 1944 and March 1945. On the 8th of June 1944, Lieutenant General Carl Spaatz, commanding the United States Strategic Air Forces in Europe, issued a historic directive. The primary strategic aim of both the 8th and 15th Air Forces would henceforth be to deny oil to the enemy's armed forces. RAF Bomber Command, though initially reluctant to divert tonnage from city attacks, eventually joined the offensive with a target list of synthetic oil plants in the Ruhr Valley. The 8th Air Force struck synthetic oil facilities in central and eastern Germany, Pöhlitz, Zeitz, Magdeburg, Merseburg-Leuna, Ruhland, and crude oil refineries around Hamburg, Bremen, and Hanover. The 15th Air Force, operating from Foggia in Italy, concentrated on Ploești and the Austrian refineries around Vienna. The results proved catastrophic for Germany. By May 1944, German aviation fuel production stood at 156,000 tons per month. After the intensified bombing campaign began, production plummeted to 52,000 tons in June, 35,000 tons in July, and just 17,000 tons in September. Albert Speer, Reich Minister of Armaments, warned Hitler in August 1944 that if the refineries could not be protected, by September we shall no longer be capable of covering the Wehrmacht's most urgent needs. He was correct. Luftwaffe training schools shut down for lack of fuel. Fighter squadrons received insufficient petrol to mount effective defensive operations. Panzer divisions in France and the Low Countries frequently exhausted their fuel supplies during combat operations and had to be abandoned or towed by horses. The impact extended beyond military mobility. Synthetic oil plants also produced nitrogen for explosives and synthetic rubber. As oil production collapsed, so too did ammunition output and tire manufacturing. The strategic bombing survey conducted after the war identified catastrophic damage to the German economy, with the oil campaign described as probably greater than any other single factor in the final collapse of German industry. If you are finding this interesting, a quick subscribe helps more than you know. The Germans attempted to counter the Allied oil offensive through several means, but each proved inadequate. Fighter defenses around major synthetic oil plants intensified, with some installations protected by as many as 300 anti-aircraft guns. The Luftwaffe designated oil facilities as priority targets for defensive operations. But by late 1944, Allied fighter escorts, P-51 Mustangs, P-47 Thunderbolts, P-38 Lightnings, had achieved air superiority, and German fighters increasingly lacked the fuel to mount sustained defensive patrols. Desperate measures followed. Workers constructed elaborate camouflage systems and smoke generators that could shroud entire refineries in artificial fog. The synthetic oil plant at Merseburg-Leuna was hit 22 times between May 1944 and April 1945, with German repair crews working frantically between raids to restore production. 6,552 bomber sorties dropped 18,328 tons of ordnance on that single facility, reducing its output by 91%. At Ploești, Romanian and German forces deployed some of the most concentrated anti-aircraft defenses in Europe. Yet the incendiaries still found their mark. Once a fire took hold in the maze of pipes and storage tanks, no amount of flak could extinguish it. The Americans and British occasionally employed variations on the incendiary theme. White phosphorus shells and bombs created smoke screens and started fires, though they lacked the sustained burning capacity of thermite. Napalm weapons appeared late in the war, though primarily in the Pacific theater. But for European operations against industrial targets, the British 4-pound and 30-pound incendiary bombs remained the weapons of choice, their effectiveness proven by the billowing smoke columns photographed by reconnaissance aircraft in the days and weeks following raids. The legacy of the British incendiary bomb extends well beyond its immediate tactical success against petroleum infrastructure. The weapon represented an early realization that industrial warfare required not just the destruction of facilities, but their sustained disruption. A crater could be filled. A collapsed building could be demolished and cleared. But a petroleum fire, once started, consumed the very resource the enemy needed most. Post-war assessments by German military leaders reinforced the weapon's significance. Luftwaffe. General Adolf Galland, one of Germany's most successful fighter aces, stated that the Allied oil campaign was the most important of the combined factors which brought about the collapse of Germany. Albert Speer wrote in 1970 that the bombing of oil facilities meant the end of German armaments production. These were not mere attributions of defeat to overwhelming Allied resources, but specific acknowledgments that the loss of petroleum mobility had paralyzed the Wehrmacht more effectively than any other form of strategic bombing. The incendiary bomb influenced post-war weapons development. Modern thermobaric weapons employ similar principles of sustained high-temperature combustion. Fire suppression systems in industrial facilities worldwide incorporate lessons learned from wartime petroleum fires. Military planners continue to recognize that an enemy's energy infrastructure represents a center of gravity whose disruption can cascade through an entire war machine. Examples of the weapons themselves can be seen in museums across Britain. The RAF Museum at Hendon displays both the 4-pound and 30-pound incendiaries, their innocuous appearance belying the devastation they caused. The Imperial War Museum holds extensive documentation of incendiary bomb production and deployment, including Ministry of Supply manufacturing specifications and post-strike reconnaissance photographs. Some sites in Germany still bear scars from the fires these weapons started 8 decades ago. June 20th, 1944. Hamburg. As the sun sets, the 3 oil refineries continue burning. Fire brigades have abandoned attempts to suppress the blazes. The petroleum itself fuels the inferno, fed by hundreds of thousands of gallons leaking from ruptured storage tanks. Tomorrow, reconnaissance mosquitoes will photograph the damage. Next week, RAF Bomber Command will return with another load of incendiaries. The month after, production will fall another 15%. By September, this complex will contribute almost nothing to the Reich's dwindling fuel reserves. Between 1941 and 1945, RAF Bomber Command and the USAAF dropped approximately 80 million 4-pound incendiary bombs on enemy territory. Of those, a significant proportion fell on petroleum infrastructure. Each bomb burned for 10 minutes, but the fires they started burned for weeks. The Reich, that had sought to conquer Europe through mechanized warfare, found its panzers immobile, its aircraft grounded, its logistics paralyzed. Not because of dramatic 1,000-bomber raids or precision strikes against ball-bearing factories, but because small aluminium tubes filled with thermite had set its oil refineries ablaze. The weapon was simple. The effects were catastrophic. And in the calculus of industrial warfare, that proved sufficient. If you liked my video, please share your opinion in the comments box and subscribe to the channel. Also, turn on the bell icon so that the latest videos like this keep reaching you. See you in the next video. Take care and goodbye.